Professor Bottano is gathering data on the growth rate of a certain new hybrid seed. He spilled coffee on his clipboard and destroyed most of the data, but he did remember that the seed had been growing at a constant rate throughout his observations. Help him reconstruct the data. So we need to figure out the missing values for Professor's table. So he knew that the seed had been growing at a constant rate. So we know that from 3 to 12 he went up 5, and the x values he went up 2. So that means from 1 to 3 he also went up 5. So that means that's 2, because 2 plus 5 is 7. Here we went plus 2. So right in the middle of 2 and 7, let's see, that would be 4.5. Because 2 plus 2.5 is 4.5. 4.5 plus 2.5 is 7.5. So then I'd add another 2.5. So that'd be 9.5 plus 2.5 is 12. So each time we go up, we're adding 2.5. So that means from here to here, we added plus 2.5. Plus 2.5 plus 2.5. So that means we started at negative 0.5. So the plant's daily growth rate is 2.5 inches per day. What is a possible explanation for the height of the plant on day 0? So on day 0, it's negative because the seed is in the ground. Write a function for the height of the seedling in terms of days. Use h for height and d for days. So my growth rate is the slope. And we know that that's 2.5 inches per day. And the height on day 0 is the y-intercept, which is negative 0.5 inches. So our function would be height equals the number of days times 2.5. So 2.5 times the number of days minus 0.5 for how much it started underneath the ground. Determine and explain the domain and range of your function. So for this plant, the domain is the x values. So the possible x values, since we couldn't have negative days, we couldn't really have negative time. So the x values, or the days, are greater than 0, or greater than or equal to 0. For the range, well, for this domain, you may also write it as 0 is less than or equal to the number of days, which is less than infinity, because the days could go on to infinity. We could theoretically measure this plant all the way until infinity. The range, we know that the lowest that the point is going to be is at negative 0.5. That's the lowest height that it's going to be. And I guess the height could go on to infinity, but it probably won't, because eventually the plant is going to stop growing. So we'll say infinity, or whenever the plant stops growing. So whatever the height is when that plant stops growing. Use the grid below to create a graph of the data. So our independent variable is number of days, and our dependent is height of plant. So we know that we're going to want to go up to day 10 and up to 20 inches because that's what we're being asked to solve. So here we have 12 inches and up to day 5. So maybe we can count by twos. So like 1, 2, 3, 4, 7, 9. So that's day 10, and we know we want to go up to 20 here. Maybe we can still go by twos. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh no, we can't. We'll have to go by ones. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we know on day 1, or on day 0, the height of the plant is negative 0.5. So this is 2, 4, 6, 8. So negative 0.5 would be down here, because that's 0. So it would be like right there. On day 1, the plant is at 2. On day 2, it's at 4.5. On day 2, 4.5. On day 3, 7, and then 9.5. 7, day 4 is 9.5. So each time we're going to go up 2.5 and over 1 day. So let's see, if we go up 2.5, that's 0.5, 1, 2, and over 1 day. Up 1, 2.5 over 1 day. Up 1.5, 1, 2 over 1 day. Up 1, 2.5 over 1 day. Up 0.5, 1, 2 over 1 day. Up 1, 2.5 over 1, 2. So here's our graph. It's linear because it's adding by 2.5 every time. So the height of the plant on day 10. So there's a couple of ways we could figure this out. We could look at the graph. We could look at the graph on day 10 and see that the plant is right here, which let's see, 20, 22, or no, 21, 22, 23, 24.5. So the height of the plant will be 24.5 inches by looking at graph. We could also plug this into the equation. So our equation is height equals 2.5 times the days minus 0.5. So if we plug in day 10 here, then we get the height equals 2.5 times 10 minus 0.5, which is 25 minus 0.5, which is 24.5 inches. When will the plant be 20 inches tall? So we could also do that by looking here on the graph. We can go over 20 inches. See, that's right here. And we go down. Looks like it's a little after day 8. So in between day 8 and 9, it will be 20 inches tall by looking at graph. We could also do this with the equation. So we want to know when the height, so that's when h is 20. So we plug 20 in for h and we get 2.5 d minus 0.5. Then we have to solve for d here. So we'd add 0.5 to both sides. We get 20.5 equals 2.5 d. Divide by 2.5 on both sides to get d by itself. and then use a calculator to get 20.5 divided by 2.5, and that's 8.2. So it would be in 8.2 days.